Good afternoon, ladies and gentlemen. I have one quick administrative announcement before we hand it over to our speakers to kick off this session. This session has been pre-qualified to support continuing education requirements for several cybersecurity certifications. If you are a member seeking attendance documentation, please be sure to scan your badge at a scanner located in the back of the seating area at the conclusion of this session. Scanners shut off 15 minutes post-session, so please get your badge scanned before networking with the speakers. Also note that to qualify for CEUs, CPEs, the session must run the full 60 minutes. That 60 minutes can include Q&A, so please have questions ready for the speakers to fill the time requirement. Full details on the continuing education program are available in the TechNet Cyber app and the conference website. Thank you, and now over to our speakers.
Okay, is the microphone on? Yep. Great. Okay, well, welcome. We're delighted to have the chance to share some of the work of the AFCEA Cyber Committee. We're one of, I think there's about 4 standing committees at AFCEA International. And the Cyber Committee is comprised of both government, industry, and academia folks. We meet on a monthly basis, and we develop a number of thought pieces. We conduct webinars and seminars and support conferences. The topic that we want to talk about today is called Secure by Design Next Steps, and it is the summary that we're going to present is really captured in this paper, which is available on the AFCEA website. You can go to AFCEA and just go AFCEA Cyber Committee and then look under the papers, and you'll see that this paper, which was recently produced, is there. And so if you want additional information, you can do that. Look at the website. The paper was actually authored by a group, a subcommittee of the AFCEA Cyber Committee. Today what we have is a subset. So I'm John Gilligan. I happen to be a co-chair of the AFCEA Cyber Committee. We've got Magdalena Logrande, who is a member of the Cyber Committee, and James Stanger, who is also a member of the committee. And they, along with about 5 other people, were the authors of the report. What I would also advise you, when you go to the AFCEA Cyber Committee website, take a look at some of the other products that have been produced by the Cyber Committee. One of the more recent efforts has been the development of a national innovation strategy. This has now been provided to the new administration for their use in potentially trying to re-stimulate the innovation activities within the United States. There are papers you'll find on artificial intelligence, secure by, or what am I thinking now? Let me. Zero Trust is what I was thinking of, sorry. Zero Trust, and in particular, the focus of our Zero Trust effort was on not the technical activities, but really the culture change that is very important in Zero Trust implementation. In fact, when we started this effort now, probably 2 years ago, looking at Zero Trust, we had discussions with a number of the individuals across the government who were working Zero Trust, including Randy Resnick, who is leading the DoD efforts. And we actually engaged in a discussion with Randy about culture change necessary to implement the Zero Trust concept. It has now become more common in the discussions when you talk about Zero Trust, but back a couple of years ago, this was not something that people were talking about. They were looking at it strictly as a technical activity. So what we're going to do this afternoon is I'll kick off the session and provide a little bit of background of why we undertook this paper. And then Magdalena is going to talk a bit about some of the research that we conducted and in trying to get deeper understanding of what really is best practice in software development in producing systems that are highly reliable and more secure. And then James is going to talk about the recommendations that we have. So to kick it off, let me just say that my background now goes back quite a few years, and included in my background is some early work now in the 1970s and 1980s in efforts that where we were looking to try to develop and actually in some cases mathematically prove the security properties of software. And that at that time, there was a very significant effort that was undertaken. The National Security Agency had formed a computer security center, National Computer Security Center. This center had produced a set of guidebooks, including what is now been affectionately referred to as the Orange Book because it was an orange cover. And it defined a set of measures that would be required to meet the criteria that were identified in this Orange Book. And the criteria were allocated to various letter grades, from letter D for having minimal security to letter A, where systems were intended to be used for very highly sensitive, potentially classified information. And so back then, there was a significant interest and investment in this activity, and there were a number of companies who developed products that went through the NSA National Computer Security Center evaluation process and actually then were evaluated as meeting the various criteria, a number of them at level C, some at level B, and a few at level A. Now, why do I mention this? I mention this because back then we had a fairly good process and we had some understanding of what we thought was necessary in order to be able to provide software-based systems that were highly reliable and secure. So what happened? And that's really the entree into the paper of, well, if we sort of understood this back now almost 50 years ago, what's happened in the intervening period? Because as we look at today, what we realize is that virtually every software system that is developed and fielded has fundamental weaknesses in terms of their robustness, reliability, and therefore their ability to provide adequate security. A little over a year ago, the director of the FBI in a congressional hearing mentioned that the Chinese had a program to basically infiltrate many of our critical infrastructure systems, exploiting weaknesses in the software design and development. And so we go from a 1970s and 80s, we're trying to do things like mathematically prove and very rigorous evaluation by a team at NSA, to the current state where systems have been developed and deployed primarily for their capabilities and not for their robustness and reliability. And so, what ended up happening, and so the paper examines that. I'll go through it very quickly. From my perspective, as I look at what happened in the 1980s and then early into 1990s, the problem with the process that was developed by NSA was they were seeking perfection. They were really trying to achieve extraordinarily high levels of robustness, and in order to achieve that, the process that they set forth was something that took many iterations for companies to get through successfully. And so companies were having to spend a considerable amount of resources to be able to get through the process, to get the, as I mentioned, this letter designation of B, C, or A in order to be able in some cases, to be able to meet requirements of the government. And what ended up happening then, and maybe I should add, This is not a surprising thing if you understand the culture of the National Security Agency. You know, their mindset is one that they are trying to protect the American public from potential misstep, and so they wanted to be extra cautious. And in hindsight, that was a mistake because it ended up driving the process to be overly long, overly costly, and as a result, many companies then started to say, wait a minute, I'm not sure this investment is worthwhile. Now, subsequent to that, as they closed down the NSA activity, as I mentioned a minute ago, we sort of moved into the era where functionality was king. You know, internet was blossoming. Web access came with it, and so the intent then was let's get things most quickly to market. And so what we've ended up with now is a legacy of many decades of software that was not developed with any particular security objectives in mind. And so the technical debt that we now have is quite enormous. And so when you fast forward to the last 10, more importantly, last 4 or 5 years, what you see is there has been a number of efforts that have attempted to say, wait a minute, we need to do a lot better job in security. And so you've had Carnegie Mellon Software Engineering Institute, the MITRE Corporation, NIST, most recently the DHS CISA organization that have been producing documents that have identified the best practices for improving the quality of software. And so as a group, our committee looked at those efforts and found that while they are laudable, they lack a couple of important things. And the first the thing that they lack is they, in general, are not measurable. And so as an example, I'll give you recall that in last administration, DHS CISA was looking for attestation against secure by design principles. Now, as I look at that as as somebody trained in computer science, I say, well, I can either attest, and they can never hold me accountable because there's no criteria against which they can evaluate, or I can say I will never attest because they may decide arbitrarily what they think it should be, measured. And so it was a well-intended effort. I don't think people were malicious. They were trying to create interest and push forward. But without measurements, it's really not all that useful. The second area which we found was lacking was if you look at the documents that have been produced, so the NIST documents, the DHS CISA documents, it is a very long list. One would say it's a catalog of security development best practices. But the question is, do I do them all? Well, that's not really possible in most cases, especially given the state of where we are. We're in a sort of infancy. So if I don't do them all, what subset should I do? What's the priority? So the second issue is there should be prioritization among those best practices to indicate which are the ones that we think are most important, that we want to get started with to improve the quality of software. So measurable, prioritization, and the third, and Magdalena will probably talk a little bit more about this, is motivation. How do we motivate the software development industry to develop software such that it is higher quality, that's measurable, and in fact, it aligns with what we think are the top priorities. This is an area that the federal government has really struggled with, and so the observation that one would make is that in many cases the federal government has been reluctant to challenge the industry to say you must dramatically improve the quality of software. That's a problem. We have to get to the point where the federal government, if they choose, is willing to not just say, hey, these are some voluntary measures, but these are the things we're expecting. I would note that one of the efforts in the last administration was their attempt to improve security was by regulation. And so what they chose was, the approach was, again, I think well intended. Those organizations that had regulatory authority, they were issuing regulations on what types of security controls and security assurances must be provided by these industries. And many of these industries are the critical infrastructure industries, but the effect of what they were doing is, my term, they were blaming the victims. The victims were in fact getting software systems from vendors that was of poor quality, poor security, and then they were getting regulations from the government saying, you, as the end user, better fix it. In my view, that's sort of blaming the victim rather than going to the source. And so, as I said, Magdalena will talk about, so that's sort of the nature of the problem. Can we identify measurable priorities and get the right motivation? We did some research. We looked at a number of organizations. Magdalena will summarize that, and then James will talk about the recommendations that we think are eminently executable. So Magdalena?
Yes, thank you for the introduction, John. Yes, so to advance the conversation about secure by design and what the next steps would be, we interviewed technologists, technical leads for several organizations, and neither stated that this was easy. I think that there's a general consensus that it is a hard problem, but it's a necessary one that we have to solve. So we focused the discussion on progress, on what recommendations they had, what was working for their teams in terms of producing more secure software, because security is not an absolute, in a consistent, repeatable manner that could be validated. And we identified some shared characteristics. I would say that the one that stood out for me the most personally was the deployment or the employment of secure software application development frameworks that already, by default, enforcing security implementation, security validation, freeing the developers from having to focus on those security functional requirements and letting them do what they enjoy, the most enjoy doing. So it becomes transparent. However, another shared characteristic was the blending of development teams and security teams into purple teams early on in the design stages. For that necessary cross-pollination, really, joint ownership of security outcomes. And another one was, tight control of the code. Doesn't mean that, open source, it's not going to be in the picture, but control of your code base, and an increased adoption of memory-safe languages that will significantly reduce certain classes of vulnerabilities that I think those vulnerability classes that are associated with memory-related vulnerabilities amount to about 70% of current CVE. So those are some of the shared characteristics that we identify when speaking with those organizations, those entities. I also want to expand on the motivational aspect of secure by design and why it is so hard, because we've been talking about moving security to the left for a number of years now. And but when you ask development teams, sometimes they don't necessarily know what that means. I cannot claim to know exactly what that means. I think in theory I do know what it means, but how do we do it? What are the inhibitors that are preventing organizations from adopting secure by design practices? And I'll start with design, because design, or good design in any case, has to be based on requirements. And very often security is not identified as a requirement, or not as a core requirement, or I would even go further and say a functional requirements. So we have this divide between functionality and security, which I think it's in many ways it's a fallacy. I think if we're concerned about mission systems and critical infrastructure, we need to look at security as a functional requirement. In a way, analogous to how the aircraft manufacturing industry or the automotive industry would look at safety. But I think that is an inhibitor. There is that divide that is preventing the adoption of secure by design, because you don't have security, again, identified as a requirement that development teams are going to consider in the early stages when they're making decisions that are going to be that are going to affect the rest of the development life cycle. But let's just say that there are security requirements. Then you have product teams where the divide is between the developers and the security experts, and they don't necessarily talk to each other. Or maybe the development team will start designing the system and and think that they can actually apply cybersecurity requirements later on as an add-on, the proverbial hardening. So in essence, that causes an endless deferment of cybersecurity risk acceptance. In essence, that moves security to the right, which is the opposite of what we're trying to do, and organizations end up with what I would call a patch-based risk management approach, and just tons of security technical debt. And then the third incentive, more in the from a market perspective, is product teams are not going to have motivation to adopt secure by design principles and produce applications that are secure out of the box if there's no market demand for those products. So there's got to be a degree of consumer education that drives consumer behavior. I think in our industry, we'll probably want to see those security functional requirements identified in acquisition language, and that will in turn give those product teams those security requirements to start with. That will drive a virtuous cycle that will gradually promote those secure by design practices. So I think incentives are an important a critical factor to consider, because Joe mentioned having a standards that are discrete, that are clear, concrete, that are measurable, and they're not and they can be adopted because they are a finite number, not hundreds and hundreds of principles. But at the end of the day, we have to have the culture in place with those motivators, so that we have product teams that adopt the standards. So,
thank you very much, Magdalena. One of the things about recommendations is the importance of secure by design needs to be recognized by both the business and the technical elements of it. So we have specific recommendations listed in the white paper, but I do want to mention something. I've had certain leaders say, well, with companies committing to secure by design or secure by default, and I realize those are two related, kind of dissimilar, they're similar things, they will often say, well, if things are secure by design, why do we need to worry about cybersecurity in the first place? If things have shifted left, if the code is already secure by design, what do we need to do? Why would we need to do anything? Because a lot of leaders are very interested in cutting costs and creating efficiencies. So the secure by design movement can be misunderstood on the business level. It's one of the first things I wanted to point out. and that I think one of the first things that you build into the secure by design kind of approach is a realization that iteration is critical. And iteration comes from the word journey. It means you keep trying. You could use the fancy word heuristic, which is basically where it's not just circular, but there's a progress here, where you don't get it right the first time, but you eventually get it right. I think that's one of the first things that's really important, so that you work iteration into your secure by design principles. Additional things that I couldn't help but think about when you were, Magdalena, said really good, some great points about taking control of the code base and things like that. I think there is definitely a race condition that exists. That I think it's one of the unspoken rules between the creativity of coders, because they want to be creative, and cybersecurity. There's always that race condition there. And cybersecurity slows, at least the perception is that it slows coders down. I don't know if you would agree with, I'm not saying that's true, but it's certainly a perception out there. Do you find, Magdalena or John, that to be something that you've run into?
I would say, James, that I think the perception is what you state.
Yeah.
And I think in part it goes to Magdalena's point. It's because there's less motivation. And I would just go back to some of the companies that we talked to. One of the things that was very important was the culture of the organization.
Yeah.
And the companies that we talked to, their statement was, our business depends on the reliability of this software.
Yeah.
And if it is not reliable, then we as a company are in trouble. And so that culture
Number one, the
pervaded
culture,
all of the development teams and their practices. So yeah.
So the primary concern is to put in place things into the culture. For example, as one coder or one group creates code, another group signs off on its quality. And that quality involves not only things like availability, et cetera, but it includes basically the secure software development concepts and principles. And I think that's something that's really important. So there's really a change in the culture and the organization. Would you anything to add to that, John, in terms of that? But it was the idea of two-person or two-group accountability and formal sign-off, and that makes a lot of sense.
Let me add one additional thought, James. I was struck in our interviews by the statement of the companies that we have an environment where we encourage discovery of problems. And we celebrate when we find a problem and we go fix it, rather than, this is something to be shied away from or swept under the rug. And of course, early discovery is one of their objectives. They use a lot of tools to be able to try to get, squeeze out as many of the hidden issues as possible. But it's, gets all of this. This culture, is marked different from companies that perhaps many of us are familiar with.
And I think that goes to the second point here, the idea of the risk management and risk understanding of the threats and things like that, and really going into understanding a formal process. Is there something baked in to the organization and through its security policy to basically identify specific risks and to prioritize processes that discover those risks? I think that's the second point that we wanted to address in the white paper. Also, the idea of creating a development environment that's not bifurcated or not fractured. In other words, you need a single environment in terms of development, I think was another recommendation. And that single environment not only includes an environment of using and creating code in your own company, but also partners. I think one of the things that we noticed in the interviews is that there are a lot of recommendations that are made for internally in a company, but they kind of forget that a lot of organizations or companies use partners, and you have to make sure that they have their code development figured out as well. So I thought that was another recommendation that was very important. Several other things I think is summarized by the need for measurement and metrics. the last hour. Bill Newhouse and I and some folks from Vectra AI, there's Bill over there, and GDIT, we were talking about the importance of measuring the success. And I think that's just a really critical element. What are you doing to basically, with your development environment, to measure what's going on? And you have the CIS, for example, you have that. You have all sorts of ways in which you can do that, but there have to be metrics that everybody agrees on. And so that's another key recommendation, is the use of discrete metrics. And the final one basically had the idea of what dependencies are there in your development environment, and how much can you reduce those dependencies, not necessarily partners, but basically software dependencies, things like that. How much can you reduce them by improving software development workflows? So those were basically the areas of recommendation there. Because what we wanted to do is we wanted to identify that technical debt is a major issue. I think everybody knows that whether it be software development or even the procurement of systems, grabbing something from the cloud, even as a software as a service solution. But as a software developer, I've talked to many software developers who say, well, James, there's a little bit of magic in everything we do. And I'm like, well, what do you mean by magic in everything we do? And he says, well, sometimes we have to move things along. And I'm like, will you please tell me okay, good, we got a chuckle here. What do you mean by move things along? And my analogy for this, and forgive me for the old reference, if anybody's ever seen the old Star Trek II, The Wrath of Khan, you ever see that? Okay, good. It's a great movie. And one of the keys is Khan finds out that there is this device called the Genesis device that if you introduce it to a planet that's barren of life, it will create a Garden of Eden. It'll just do wonderful things. Well, the person, it was Kirk's son, who developed the Genesis device, he skipped a few steps. He kind of fudged a little bit. Now, I'm not saying all developers are bad. I am saying that as we implement technology, anybody who's worked in the world, you kind of have to make certain steps or skip certain steps. That's the magic. That's technical debt, as it were. And the reason I tell you that story and that analogy is we felt that these recommendations having to do with metrics, having to do with working with partners properly, all that helps address some of the root causes of that technical debt. Because that's really some of the issues we have to worry about. And it's not just in ancient code. It's not just in the Kix system, the COBOL that's older than I am or whatever. It's in new stuff as well. So I just wanted to point that out, John. So as far as recommendations are concerned, I think what's fun about this white paper is that it came through interviews working with people who actually do software development for a living. So it was really neat to see the ability to crystallize that. So there's my summation of the recommendations.
Yeah, so let me, James, just add a couple of points to yours. So in the document, we make 4 recommendations. The first is the recommendation is that the industry should take the lead in developing an initial standard for software development that is prioritized and measurable. And so it looks at the documents produced by NIST, CISA, and others and says, what subset do we view are most important? And then let's define how we're going to measure those and publish that. And the motivation for having industry publish it is we've now developed such strong pushback from the software development industry of any government involvement. The view was perhaps we have a better luck with the software industry in getting them to agree to an initial step. So that was the first recommendation. The second was to motivate the adoption of this standard. And the motivation obviously would be, as Magdalena said, that buyers, users, reference it and say, I want products that have in fact adhered to this standard. The third was, required demonstrated proof. That is, the measures will lead to evidence that in fact the criteria have been met, and that should be publicly available and easy to examine. And the last is the recommendation that as organizations then produce software against this initial standard, that there should be some safe harbor legally for those organizations against claims of poor design development, that wait a minute, they have followed the standard, and for a certain level of safe harbor they would be assumed. Now, this safe harbor issue is a huge issue in the court systems, and in fact, I will mention that James mentioned, I'm from the Center for Internet Security, and one of the products that we have produced over time has been a set of what we call the critical security controls. This set of controls follows the same principle as we're talking about in software development. It takes the large body of controls that exist in NIST and other references, it prioritizes them, and it says this is how you measure them. So it is. We've actually taken this critical security controls, working with the legal community, some judges and court professionals, because they're trying to determine what's the standard of what we're calling standard of reasonableness. What's reasonable for organizations to have done, and so we're looking at. They have now adopted that as an initial standard, and we're looking at this from the standpoint of software in the same mindset of, okay, if you adhere this. The last thing I would mention, and then we can open up to questions, is following this paper, my organization, Center for Internet Security, is working with SafeCode, an organization of software developers, to see if we can't produce this initial standard. And so that work, the folks are optimistically targeting the end of the year to have a subset of software development principles that are prioritized and measurable, that then would be the SafeCode community hopefully would endorse, and we would be one step down the road of trying to get a broader industry adoption and implementation of this standard. We'll see whether it works, but I think in my discussions with a number of companies are almost as frustrated as the user community, the software developers. They realize they need to do something. What they haven't found yet is the government actions have tended to be very heavy-handed. And oh, by the way, one part of the government is headed in this direction, another part of the government is headed in this direction, and they say if we could get some coherence where we can all agree on one set of things, then we can actually do it. We can't do it if, in fact, we've got regulatory agencies issuing this, we've got the CISA folks issuing this, the White House issuing something different. And so anyway, and I'll return to Magdalena. James, anything you would want to add before we go to questions?
It's interesting when it comes to governments, like Europe is coming up with the idea through ANISA of software having to be certified. Before an application is used, it has to be certified and things like that. I wonder what that will do in terms of competitiveness, and things like that.
Yeah, my experience is Europe tends to be a bit in front of us.
Yeah.
And they stub their toe a bit, but they're more proactive in these areas than the U.S. The U.S. tends to, their argument is we want to let creativity bloom.
Yeah.
And in privacy, artificial intelligence, if you look at what is done in the EU, it's much more specific and stringent, and it's a reasonable model from many respects, but there's been reluctance within the United States to follow that path. But in this case, I'll be interested to see how that works out.
I know what you mean. It's what do you think, Magdalena? Yeah, go ahead.
No, so I also wanted to touch on that point. Like, what is that the right degree of regulatory frameworks or enforcement? Because you want to have incentives, but you want them to be more of a carrot, not stick. And I do like how one of the last lines in the paper is basically driving the point that really we think that the primary factor in adopting secure by design principles is going to come from the software industry, the private industry, in the sense that there's going to be a healthy competition, among peers,
Right.
and that's that's precious because you have that's basically inherent to the nature of what they do on a day-to-day basis. So that's really what we want to drive. But I know it's not how do you find that what's going to be that trigger that's going to motivate that inherent adoption of principles that don't necessarily have to have an external incentive permanently, but there's gonna be some triggers that are necessary that have to drive that adoption.
No, it's interesting because you've got that whole what's going to happen in terms of we have so many privacy regulations, we have so many cybersecurity regulations and things. So many people, I think, will think, well, that's where software development, can be handled, or whatever, and that's not the case. In other words, I think there are some people who think, we already have the CSF, or we already have NIST, what is it, 800, et cetera, various standards, or we have ISO to do that. But it doesn't really solve the problem of software development issues. And you're right, it's very much kind of the wild, wild west when it comes to the U.S. and everything. I am curious, will companies how should I put this, regulate themselves? Will they self-regulate? Or will it require the government to really come down and say, look, there are standards for software development because it's causing too many root cause problems for us? I don't know.
I mean, there are some models, mostly in Europe, where organizations that are in the business have developed these standards, and they comply with it. And so this is not without precedent. But I think you're right. What we'll need beyond the initial step of developing this initial standard, and it'll just be an initial because ultimately you'll want to expand it, is to get some organizations saying that, all right, I'm going to implement it, and then buyers, federal government among them, saying, I'm going to look for products that have been implemented according to this standard. That'll get the ball rolling, and I think that will start to generate the interest because the competition that you mentioned, Magdalena mentioned, that's going to be what's going to make it happen. That all of a sudden they're going to say, now I have a competitive market advantage, whereas today that's not a factor.
Not there.
Yeah.
So we have a few minutes for questions. We've got a microphone here if there's any questions that anyone has.
So I was curious, as you brought up, obviously, software supply chain is part of this. Ultimately, a lot of the core libraries that everything uses are open source, and a lot of those are written in C. And there is active desires to not rewrite it because, for example, rewriting libcurl in curl would probably introduce more issues. SQLite, which is on everyone's mobile phone in several instances as well. So where do you see that kind of sitting in there where all this commercial stuff is backed by a handful of open source projects? I think we've all seen the XKCD.
Yeah. Uh-huh.
And rewriting that is considered more dangerous than not.
I wouldn't. Personally, I would say you can't. There's no need to recreate the wheel. There's no need to do that because you're right. It would probably introduce more problems and things like that. I would say in this case, you just have to be selective in it. And I think there also needs to be in the open. I'm a big open source fan. I love. What is it? Given enough eyes, all bugs are shallow. Isn't that what Torvald said? That's one of the statements. In other words, if you have enough eyes looking at the code, and that's a big if. I'm not sure we have enough eyes looking at the code. I think there needs to be within the community some sort of best practice set up to handle the development of the code. But I think there are certain code bases that, yes, absolutely should be left alone. I do think, though, that moving forward, I think there might be some automation that can help us. AI is not ready for prime time in this area, nowhere near it. But I think that will happen. That's what I would say in broad strokes.
Let me add, in the companies that we talk to, they address this problem and other dependencies very, very specifically. So they started first with an evaluation of what are the threats that are most significant to us. in developing this software. And they applied the highest level of rigor to those portions of the software that would be potentially targeted by those threats. And in many cases, what they did is that it wasn't that they didn't use third-party software, but they would test the heck out of it. They would freeze the configuration into a known configuration, and they would isolate it. So basically, they would bound it so that it would have certain principles and properties that could be implemented, other things that would not let that software do. And so, they address this very specifically. Now, in some cases, companies that told us, for things that are of such high priority, we're going to develop our own. We're not going to rely on third party. Now, obviously, that's not a solution for everyone. But I'll tell you, one of the organizations that we talked to also pointed out, this was a government organization, the enormous inefficiency that government organizations have in maintaining open source software that's embedded. And they just indicated that they had done some, using tools. What's the version of the open source software? And many of them were outdated. And so, these are no-brainers type things. So I think open source, is very valuable. But it also, and along with other third party, you need to understand that's a risk. And so as you get into this risk management, you say, all right, is this a risk I'm willing to take? And what mitigation steps? They talked about, they address it very specifically. What mitigation steps do I want to take to be able to minimize the chances that this, third-party software, open source or other, could in fact cause harm into the software? So I don't know, hopefully that helps.
Sort of, and that kind of raises the point as well of, in many cases, the potential risks aren't something that orgs track, because a lot of these can come from the software behaving in a way that no one would have expected, log4j. So Java is obviously a memory-safe language, and congratulations, your logging component of this is now able to act as the C2 and potentially execute arbitrary code, which is not where anyone would assume that would be on their security stack.
Well, it does point out, we've been talking now for a number of years about this software bill of materials, and, the organizations we talk to, they would spend a lot of energy understanding what's under the covers of anything that we're planning to use. And so, again, this is not necessarily foolproof, and it's back sort of to the difference, I think, from when in the 1970s, 1980s, we were trying to get absolute security. Yeah. What these organizations are doing is an extraordinary amount of energy, but focused on reducing risk in the areas that have the most significant consequences. Hopefully that helps.
Yeah, I'll let others go. I have one more question, but I don't want to hog it.
Any other comments?
All right, you're
questions?
back.
Go ahead.
Okay. Okay, so last one is very much in the commercial. So I'm pretty sure Microsoft, for example, has signed the Secure by Design pledge.
Yeah.
And I think a lot of us have been tracking Windows Recall / Microsoft Recall as a feature that's been deployed to Windows. And a lot of the security community pointing out that this is the antithesis of a secure deployment of a system, where they found it would pull credit card information and the like, and a decryptable log, which is all stored there, and is highly easy to exfil. So ultimately, how do we try to mesh this when you do have such monolithic vendors that have that market share, when you are a single group policy object away from having that hit an entire enterprise?
It's a tough problem. But I'll give you one example, and in fact, I mentioned it in the paper. When I was a CIO in the federal government, I spoke at a press conference, and my comment was this, that we, in my organization, were spending more money to patch and fix Microsoft software than we were paying to buy it. And that I would gladly pay much more for the software to have higher quality software. About a year later, Bill Gates came out with the trustworthy computing initiative. And for a while, I think they had religion. That era is gone. And so it's, I think, back to Magdalena and what James has said, there has to be a change in the environment and the motivation. Because, you know, if I were king in government today, I mean, I would be happy to go toe-to-toe with Microsoft. I don't think most of our political leaders are willing to do that. Okay, fine. So the approach that we've recommended is let's get subsets of industry. Microsoft may or may not be willing to sign on, but if we can get others that are willing to sign on, then we can start to have what was described as a differentiation that will start to drive adoption by others, you know, saying, wait a minute, I'm meeting these standards, Microsoft, you're not. And one thing I do know from all my experience in buying systems, if in fact it becomes a factor that is meaning that some vendors are not getting the contracts, they'll change. They will change. And it's not that it's a trivial problem, it's huge. I understand.
Thank you.
Thank you.
Okay, any other questions? All right. Again, recommend if you want to see the paper, go to the AFCEA Cyber Committee website, and there are other papers there that you might find interesting. If you have other thoughts and ideas, you can send them our way. And I'm hopeful that a year from now, when we have this conference, we'll be able to say we've got a draft standard, and we're moving forward. And you know, we're hopefully going to see some progress in this area. It's such a shame for all of us when you look at the poor state of quality of our software. It's sad, and it's become both a national security and an economic security problem for us as a nation. And I think, unfortunately, far too few people really understand. And it really needs to be solved at the engineering level. It can't be solved at public policy level. So. All right, with that, final words?
If you, the very web page that you read to come to this, the AFCEA TechNet Cyber web page that lists the three of us, if you go to the bottom of that, there is a link where you can easily get to that paper. You have to fill out your email, et cetera, but then you can get the white paper that easily. So just wanted to add that. And thank you very much, Magdalena and John.
Yeah.
Appreciate it.
All right.
Thank you for joining us.
Thank you.
Take care, everyone.